that you wrote for your experiments in your notebooks. Okay. So I need you to pull out those hypotheses.
It's this week? Oh, I thought you said we were doing it this week. I was like, that means today. I'm not ready. We have our hypothesis.
Okay, so let's look.
What?
Stand up here. Alright, so let's look at my hypothesis for an example for just a second. Okay? One thing that Mr. Hayes talked about with you on Wednesday about your experiments was doing something that you could measure, right? And so how did I include measurability in my hypothesis? Okay, I'm going to go back here. The front of the room has actually done pretty good with answering questions. So let's go from here back. Who in here can tell me, how did I include measurability with my hypothesis?
The amount of glue that it produces.
Okay, so I was measuring or including the amount of glue I added. Okay, perfect. How about in my results? How did I include what I wanted in my results?
That's the one that's always harder,
Right? It's easy to control your variables, right? What you add, what you don't add, what temperature. What about the results? How did I get measurable results based upon my hypothesis? Okay. Perfect. So I said it was going to, the bounce will increase. It will bounce higher. So now I can measure how high it bounces. Okay, what would have been a bad example? How could have I reworded that in a bad way? We don't usually do this, take a good example and make it bad. But how could have I done not as good a job?
Mr. Huntsman, can I share one that I see
Yes.
all the time? Here's what a student of mine might have said, even in this class or one of the other classes. As I increase the amount of glue used in the recipe, it will bounce better.
It will bounce better. Okay, so how do you measure better? It's subjective. Perfect. Okay, right on. Okay, and so as scientists, we have to be really careful about using subjective measurements. Okay, what I thought about when I was first writing this is kind of along the same thing, that it will be a better bouncy ball, right? Okay, so what makes a better bouncy ball? Right, how kind it is, how nice it is.
What color it is,
What color it is,
how much it costs.
what brand is on it. I could put a Nike symbol on it and it would be the better bouncy ball, right? And so we have to really make sure that what we're asking in our experiment is measurable. Okay, sometimes in some things in the scientific community, you can't get measurable data as far as measuring something. Sometimes if you ask, let's say you're a psychologist, which is a branch of science, and you want to know if this way of talking to people makes you happier, okay? It's kind of hard to get data that you can measure with a yardstick, okay? You could do a scale of from 1 to 10, how happy are you? Okay, but most of the things when we're talking about chemistry, we can measure with temperature, or length, or time, or whatever it may be.
Mass.
Okay? Mass. So we're going to look back at your experiment, or your hypothesis with your partners that you were assigned earlier. And you're going to look at them and say, okay, is my hypothesis asking something that's measurable? Okay, and if not, how can I rewrite it just, a little bit to make it measurable? Okay, I'm going to give you about a minute and a half. okay, to talk about those, and then we'll come back together. Okay, any questions? What we're doing? All right, get started. Here you guys discussing.
I don't think that would affect the temperature.
Hey David, is Grant okay? Is Grant alright?
What happened?
That was fun though. That was fun though. I just see Jake, see Grant.
How'd you do?
What were you guys doing anyways? David. What were you guys doing anyways? No, I do. I didn't realize that.
All right, so I need, we'll say 3 volunteers. Okay, who would like to share theirs up on the board? Okay, so 3 people. And I would like, if you think that you have an awesome first example, you nailed it, okay, write your first example up. Okay? If you found a really good way to improve from your first example to your second example, I want you to write both of your examples up on the board. Okay? So I need at least 2, but we're going for 3 people who are very brave. No brave people?
They're all cowards.
That was written up there before. Yeah, that's Mr. Hayes.
Yeah, you can erase it if you need to.
Okay, I need 3, or I'm gonna just have to close my eyes and point. Okay.
We better do that right now so we don't waste any more time.
I know what you did for your project, and I'm going to use yours as an example. Okay. So, would you be willing to write yours up on the board? All right. I'm just really drawn to the blue of your beautiful. So, would you be willing to write yours? And people over here think they're safe.
Are you snack?
Wait, there was an Eden in this classroom.
Do you smoke lunch?
Okay, Eden. Would you be willing to? Actually, my wife's name is Eden, so I picked it up on Wednesday.
No. That's a real fat chair.
All right.
I'm not like that. I need to know.
So, by show of hands, while they're writing, okay, who feels that their second hypothesis is now, we're trying to say, I want to not say better, but who thinks it's more effective in asking a good question than their first one? By raising hands. Did anyone improve for their first to second hypothesis? That's what we're asking. You don't know. Okay, so are we a little unsure of what we're looking for?
You made me read that.
Yeah, we're looking for quiz number 2.
That's day. Metric stairs.
We're not doing this.
Everyone did that in 5 different ways.
All right, perfect, thank you. Okay, we're gonna start with this first one that's complete. Okay, so this first hypothesis that I think that ice will melt, ice melt will work better than melting ice. So those are 2 brands of like icing stuff?
Well, there is ice melts and salt.
Okay, gotcha. So I think that ice melt will melt more ice. Okay? So, let's give him it, okay, everybody. Can you focus up here? Do you want to stop?
You just, Mr. Huntsman, just raise your hand like this and leave it there until they raise their hand. Then you'll know who's looking at you.
Okay, we need to focus up here. Okay. Alright. So, we're going to ask, what was being measured? What were you measuring in your experiment?
I was measuring how much of the ice would melt with a given substance.
Okay. So what units did you use in measuring?
I used inches, so how deep the ice was
Okay.
after a certain time.
Perfect. Okay, so how could you put that in your hypothesis? Including that depth.
I think that ice melt will melt more of the ice down first.
Okay. Okay, so you're getting there. You're getting there. You see, this is a process of understanding. Okay, what we need to talk about is you were looking at depth specifically about ice, right? Okay. So in his hypothesis, he needs to include will decrease the depth more than this other one will decrease the depth. Okay, and then we can measure the depth, and we can measure the depth of this one, and we can compare them, and have a very good one. All right, what else? The cake will rise more in the oven. The height of the cake will increase in the oven with extra baking powder. Perfect. So what is she measuring? Height. Okay, what units can we use? Inches, centimeters, meters, kilometers, if you really wanted to.
That's a big cake.
Okay, what about this one? Okay, and I pulled her out because I know that this one was going to be a difficult one to reword. Okay, I put her on the spot with this one. Okay, so she's measuring creaming, right? So how did she reword it? Will make my ice cream more thick. Okay, so how are we going to measure thickness in this example? Okay, some of these are hard, right?
The viscosity test he was talking about the other day.
Yeah, on Wednesday, Mr. Hayes talked about maybe a viscosity test, right? And then with the viscosity test, we could have numbers. Okay, scientists, we love numbers, measurements, to be able to analyze and see which one did which one. Okay, is this making a little bit more sense?
Mr. Huntsman, can I add something to your comment?
Yes.
You know how we talked about that viscosity thing last time? Everybody look at this little deal. Now think with me, if I have this on a flat surface, right? And we've got this incline, and we put a piece of wax paper on it. And then I dropped molasses, 1 drop of molasses, and 1 drop of water, and 1 drop of oil, all at the same time, like I had people help me, right? 1, 2, 3, go. Put a drop on there. What's going to happen to it? The most viscous, the one that's the thickest, and least likely to move, is going to what? It's going to move the slowest, take the longest, right? The one that's the least viscous is going to... So, what he's talking to you about now is how you might actually carry the experiment out to find that viscosity. Okay.
All right, any questions? We're going to move from our hypothesis and experiment. Okay, so any dying questions you want to ask before we do? All right, perfect. Okay, so the next big thing of all these experiments that you've been doing have been to see real life, real world application, right? Whether it's making ice cream thicker, creamier, or whether it's making cake rise or deep icing your driveway. Okay? All of these are very real situations that we face, especially the ice here in Rexburg, right? So, when we take what I made, okay, and look at it in a scientific, I made a bouncy ball. That's a pretty common, everyday item, right? So what I actually made was, in scientific terms, a polymer. Okay, do you remember talking about polymers?
Sodium polyacrylate is a
Superconductor.
Okay,
It's a super absorbent what? Polymer.
okay. So a polymer, okay, so we have monomers and we have polymers. Okay, so a monomer, mono means one, is one unit. Polymer, poly means many, and so it has many subunits in it. Okay, you think of a chain, right? So what would be the monomer in the chain? So chain. What would be the monomer? What's the single unit? One link. Okay, and then the polymer would be the whole chain, right? Okay. So, and I don't have a good example of what exactly I